Hello everybody and welcome to the GCSE Geography Paper 1 live stream. It is so lovely to see so many of you guys here. I hope your religious studies and biology paper 1s went well. I know that the AQA wasn't as expected in terms of biology, but I hope that my religious studies live has helped you. For those of you that attended the English literature lives, I hope those helped you as well. You guys are so appreciative and that's so lovely. I've been posting a lot of your guys' comments, so I hope you appreciate that as well. So the way this live stream is going to work is I have posted a poll I will share with you now, and it's in the chat as well. You guys have voted which topics you want me to go over. The reason why I'm not going over all of the topics is because I already have 2 live streams that have done that 2 years ago. And in addition, I think I want you to do something a little bit more useful, which is to go through exam questions for each one. Thank you for appreciating my drawing. So because we're going through exam questions for each one, we're only going to be able to go through maximum of half of the topics. So make sure you vote in the poll, and once you've done that, I'm going to select the topics with the most number of votes and we'll go through those. It's not as if I'm not going to go through content. I'm also going to go through I'm going to go through both exam questions and content when it needs to be explained. Okay, so hopefully you guys have access to the poll. Coastal management seems to be quite high. Let me just refresh these. Okay, so let's start with coastal management. Okay, let's start. We're going to go through these topics. Again, if you want me to go through a specific topic, make sure you change it on the poll. So just wanted to share with you guys No Waffle AI. It's now 50% off just for you guys. It has 10 different subjects, and this is the tool I'm going to be using to go through the exam questions. So it splits all of the topics into paper 1 and paper 2. So let's look for coastal management, and essentially it has all of the specification points. It will pull every single exam question ever asked about that subtopic. So I guess we should probably just go chronologically if you guys want to go through coastal management. So let's start by looking at hard engineering. Now, because it picks through a database of literally thousands of past papers, it takes a couple of seconds to load. Whilst we're doing that, I'm just going to prepare my whiteboard so that we can go through the questions together. And the really good thing about No Waffle AI is that it adds all of the revision cards to a deck. So if you are struggling with a certain topic, then you can add that to the deck. Okay. Let's have a look. So it has pulled all of the exam questions, as you can see, and not only does it do that, it also analyzes what examiner reports have said about students' common failings. And there is actually a trend where whatever an examiner report says that a student has done badly, the next couple of years, they bring those topics and they test those skills. That's why they are so useful. So let's get started with this 6-marker that was asked in 2019. Okay, I don't want to show you the mark scheme. We can also turn them into revision cards at the very bottom as well, which might be easier. So let's just add these questions to revision cards, just so you guys don't see the answers as we go through. Okay, the really good thing is it also gives model answers as well. So it's not just mark scheme answers, it's how an actual student would be able to do it, given time conditions and all of those things. Okay, so you can see that it has now converted it into revision cards. Let's go through them one by one. So the first one is a 6-marker. This was asked in 2019. User-named example, explain how hard engineering has been used to manage coastal erosion. I want you guys to try and answer these questions in the chat if you can, or do some sort of active revision any way possible. Okay, so let's do this on the whiteboard as we work through the topics. So for hard engineering, there are various techniques, and you clearly need to show a memorized example. Okay, so you've got seawall, gabions, groins, and rock armor. Those are the different types that you can have. Okay, now what you essentially want to do is identify a named location which has a coastal erosion problem, and then you want to introduce how the hard engineering strategy has been actually used within it. So I'm going to use the example of Holderness Coast. Okay. By the way, you guys can access it at nowafflegcse.com. So looking at Holderness Coast, so the pen is a little bit too thin. Perfect. Okay. Okay, so Holderness Coast, and this is actually found in East Yorkshire. It's just good to put some sort of geographic relevance to it. Now, a lot of the time I get, can you guys answer in bullet points? Now, sometimes they mention that they want you to answer in proper English, then you can't. But when it doesn't specify that, which in this case it doesn't, you can actually answer using bullet points. So the Holderness Coast, East Yorkshire. Firstly, you want to identify that it is experiencing coastal erosion issues. So you want to say, in this case, the cliffs are made of this soft boulder clay and chalk, and as a result, it has eroded 1 to 3 meters each year. Okay, and as a result, there is clear coastal erosion taking place. Now then we want to talk about the actual hard engineering strategies. A lot of people ask, okay, how many different strategies should I talk about? You want to talk about at least 2 in this case. So the first one we're going to talk about is seawall. Seawalls have been used. Okay, and then the second one we're going to talk about is groins. Okay, so for seawalls, we could say firstly, how do they work? Well, a seawall is a wall that's made out of a hard material like concrete, and basically the idea is that it reflects waves back to the sea. Okay, and so seawall has been installed in Mapleton. This is just some added context showing that you've applied it, and also at a place called Hornsea. So concrete barriers that reflect the waves back into the sea. Okay, and what you want to say is this then prevents hydraulic action and abrasion of the cliff face. Okay, and then we can talk about groins. So groins have also been used in the same area, and they are essentially the wooden or sometimes concrete barriers that are built perpendicular to the shores. So that means at right angles, and this is to prevent longshore drift. It's very important you use the word shore because that is the direction that the water is coming in. And essentially, the job is to trap sediment that's transported away by longshore drift. Okay, and this then builds up the beach material that absorbs the wave energy before it reaches the cliff. So that's the extra line that people always forget to add when they're talking about groins, right? It's not just that it traps the sediment, it then builds up the beach profile, which can then absorb the wave energy and protect the. Okay, now we want to, well, I mean, these are a lot of points so far, but we could also discuss how this seawall has actually been effective because it reduced the erosion rate from 1.5 meters per year to 0.3 meters per year. So the actual result is something that you could also add to your answer. It reduced the erosion of the cliff face from 1.5 to 0.3 meters per year. Okay, and what about the groins? Well, the groins were also very effective, and the only issue that it did cause is it led to downdrift starvation because beaches towards the south of Cowden had actually eroded a lot faster. So that's kind of a negative there. Now I'm adding extra information. You don't have to add all of this, but this is a model answer of what a grade 9 student would typically write. So the groins are negative because it starves. Okay, so that's an example of a question. Let's see how No Waffle AI has answered it. Yes, so it's given those points. And also a point we didn't mention is that the scheme cost 24 million for only a 2.3 kilometer stretch, which is unbelievable in terms of cost, guys. Okay, let's go through the next exam question. So describe 2 hard engineering methods used in coastal management. So this was asked in 2021 and it is a 4 marker. So again, there's going to be some overlap. So I'm not going to repeat any content that we go through. So if there are overlaps, then we'll just say we've already answered the question. So let's try and answer that together. Okay. So the next one. This is only 4 marks, so we don't have to be as detailed as we just said, but it says 2 hard engineering methods used in coastal management. So firstly, it would be good to just describe what hard engineering is. That's what the first mark is for. So you'd want to say hard engineering is essentially constructed human barriers such as seawalls, groins, and rock armor that's designed to resist erosion directly. So constructed barriers, for example, seawall, groins, and what was the other one? Gabions or rock armor, which is designed to reduce erosion directly. That is 1 mark. And then you want to talk about your 2 engineering methods. And a really useful tip actually is, even though it's not explicitly asking for an example in this question, you get more marks if you mention the example just because you show you've revised it. So the Holderness Coast, you could mention it here, even though it's not necessary. It just shows to the examiner you know what you're talking about, you've revised your concepts. So again, we can talk about the seawall and the groins, okay? I just want to talk about other points so that you guys get to revise all of the different hard engineering strategies. So you can also say 1 method is the gabions. Okay, define what it is. So gabions are these wired cages that form a wall and they are basically filled with rocks. Okay, and they are built at the foot of a cliff. Okay, so that's your 1 mark for explaining it. And then you also want to talk about how it directly prevents coastal erosion. So you could say that these gabions essentially absorb the wave energy and reduce erosion. And also they are relatively cheap because of the fact that rocks are there. And so it's quite a good defense to have, and it's easy to build. 1 negative, however, is it's not aesthetic to look at. Now, another point you can mention, which we haven't discussed, is rock armor. Now, rock armor is very similar, but it's basically the fact that they're not in the wired cages. So you've got the boulders that are piled up along the coast. Okay, and as they're piled up along the coast, it's sometimes also called riprap as well. Essentially, how it operates is, again, it absorbs the wave energy, reduces erosion, and also reduces flooding. Brilliant. Let's move on to the next question. Okay, so let's look at some more past exam questions on this topic, or let's just check our answers. So yes, seawalls. This question talked about seawalls and rock armor. Large granite or limestone boulders dumped in rows along the coast. The rock armor absorbs and dissipates the wave energy through friction and percolation. So I don't know why, but the mark scheme for this 2021 paper was really detailed, maybe because it was a COVID year. Anyway, let's move on to the next question. Well, we've done a lot of hard engineering, so let's maybe do some practice on another type, like soft engineering. So I hope you guys can see how the No Waffle AI website operates. It's essentially supposed to give you an influx of exam questions for every single topic. It's really, really good. And it doesn't hallucinate. It also tells you some examiner feedback, which we haven't gone through for hard engineering. I'll go through it now for soft engineering. Again, if you want me to go through certain topics, then just note it down. Okay, a lot of you want me to go through rivers and weather transport. So once we've done coastal management, we'll look at rivers, given that some of you have. Make sure you vote in these polls to decide which topic you want to cover. Okay, so we've got some exam questions on soft engineering. So let's quickly convert them into revision cards. And as we are converting them to revision cards, let's look at some of the aspects that examiners found students failed at doing, or common mistakes. So firstly, confusing soft with hard engineering. Students would describe the seawall or groins as soft engineering because they wouldn't understand the physical properties. So remember, soft is working with nature, like vegetation, sediment, and water absorption. Hard is looking at built physical structures like concrete and steel. And guys, just want to remind you that it works out £1.25 per subject, No Waffle AI. This is just for geography. So many students have used it, and it's actually helped them improve their grades within just a few days. This I was making for the last 4 months, so definitely check it out. Another mistake is missing the cost-benefit trade-off. So a lot of students state that soft engineering is always better or always cheaper because there's an oversimplification. But of course, it depends on the location you're talking about. For example, beach nourishment in Bournemouth costs 10 million per 5-year cycle. So that counteracts the argument that soft engineering is always cheaper. Another mistake students make is the vague location names. So you have to name which specific area you're talking about, right? Are you talking about any of these examples or Holderness Coast? Okay, also No Waffle GCSE AI has some predicted questions, so it's worth looking at those. But let's look at the exam questions now. Okay, so the first one is user-named example, explain how soft engineering can be used to manage coastal erosion. Okay, so let's answer this question up here. And this question is, again, from 2018, I believe. Okay, so let's get started. Also want you guys answering in the chat to make this as active as possible. User-named example, explain how soft engineering has been used to manage coastal erosion. So again, you want your clear definition of what soft engineering is, okay? Which is essentially, as we said, schemes that are set up that are not man-made structures, and it's set up using the knowledge of the sea and its processes to reduce the effect of flooding and erosion. So non-man-made man-made, non-man-made kind of structures, or sometimes you could just start by immediately saying soft engineering is a scheme using knowledge that uses knowledge of the sea and its processes to reduce the effects of flooding and erosion. Okay, so let's look at how it has been used to manage coastal erosion. So the named example that we are going to be talking about is Porlock Bay in Somerset. So let's have a look. Always make it super clear which example you're using. Okay, so Porlock Bay in Somerset, and this is since 2010. So Porlock Bay is basically a shingle beach, and it has been protected by a natural ridge. So basically natural mechanisms have been used, different soft engineering strategies to manage the coastal erosion. Okay. So remember, soft engineering strategies, in addition to beach nourishment and beach reprofiling and dune regeneration, the EDEXCEL specification also talks about having a shingle ridge. So that's the first one we're going to mention. This would also be awarded marks in AQA because it is a valid point to put. So the shingle ridge essentially was created, and it was naturally built by the Environment Agency. It was essentially a managed retreat, and it was done in 2013, between 2013 to 2014. It was created, and it created behind it a 400-hectare salt marsh habitat. So you can see that there are secondary benefits of the ridge. Not only did it prevent constant coastal erosion, but it also allowed for habitat creation. Okay, and the protection of that. So this works because the salt marsh behind it absorbs the wave energy naturally. And because it absorbs the wave energy naturally, it showed that the wave height was actually reducing by 70% compared to open water. So that is a result. Always try and have some sort of result. Okay, and that's one example of the soft engineering strategy. Another thing that they did was beach reprofiling. Now remember, beach reprofiling is different to beach nourishment. So you've got sand and shingle from elsewhere, for example, from lower down the seabed or lower down the beach, is basically added to the upper parts of the beach to create a greater slope. Okay, that's the reprofiling. And then the nourishment is more about just creating a denser beach. And so the whole idea of beach profiling is to create the wider beaches that then slow down the waves. Okay, and as a result, because it slows down the waves, it gives more sustainable and long-term protection, which residents really do like and prefer. Now, obviously, there are many benefits of soft engineering, which is the fact that it's more natural looking, and so it doesn't deter tourism, especially in the UK when we already have such a limited amount of of beaches in general. Okay, so I don't know what's going on in the chat, but let's look at the mark scheme for this, or what a student could say. So named coastal location identified, soft engineering method described, explanation of how the method actually reduces erosion, a reference to specific evidence, like a result essentially is what you want, and then a clear link between the method and the protective outcome. And here's an example which we talked about. It also mentioned the cost, so statistics in terms of cost is important as well. You don't want to make up statistics, but if you come to the situation where you have to make up a statistic, make sure it seems reasonable, because I know we've all in one of my geography GCSEs, so you just have to be a bit careful. Okay, and look, this is a really good question. Let's now move on to question 3, which is actually comparing soft versus hard engineering. So to what extent is soft engineering a better solution to coastal erosion than hard engineering? And we're not going to repeat on the named examples because we've already mentioned them multiple times, but let's answer this question together. Now, also, if you find yourself in the rare position that you've done all of the past papers, you can also look on No Waffle AI for the predicted questions, which also exist. We are going to do a Blooket at the end. Okay, so let's think about comparative points then. So, of course, in terms of general advantages, I'm going to just structure it like a table: soft engineering, hard engineering. So in terms of soft engineering, there's significant advantages. For example, we can actually refer to Porlock Bay, right? So Porlock Bay in Somerset managed to lead to habitat creation. So I'm trying to come up with points that you guys wouldn't necessarily think of. Like habitat creation is something soft engineering allows, hard engineering doesn't allow, because of course it's human made. So the obvious points, of course, are hard engineering is much more unnatural, and therefore it's going to have likely greater opposition by maybe environmental groups or by tourism operators. Okay. So tourism operators, because of, they could argue, visual pollution, and that's going to reduce their economic benefits, and environmentalists, because they're going to think you're chucking these wired cages on top. You're literally barring off the cliff from, natural light, or whatever they say. Another point you could possibly say is, when you think about limitations of soft engineering, it requires repeated investment. Like if you think about beach nourishment or reprofiling, it requires, repeated or consecutive reinvestment. Like you have to keep maintaining it, right? So it's the maintenance, and that doesn't tend to happen when you think about the hard engineering strategies, which often are just referred to as a one-time cost. So time and money are basically aspects to consider as well. Another point you could mention is, I know this is an overgeneralization, but you could say for the most part, soft engineering strategies are cheaper, or at least for their first time cost, right? Their first time implementation, they tend to be significantly cheaper than forming a whole seawall or doing anything like that. And so they are, as a result, much more likely to occur and much more likely to be operating, right? Local governments don't want to spend that much money on preventing something. They've got loads of opportunity costs of other things that they need to spend their money on. Okay, so let's have a look at what the mark scheme was saying. So definitions are clearly stated, and it has some examples here. So the seawall provided immediate 100% protection. So maybe that's a lack of soft engineering, because it doesn't provide that, overall benefit. And also conclusion is necessary in this case. This is quite a really esteemed conclusion. A grade 9 student would say this. So they've really applied it and thought, okay, soft engineering is going to be better for low population groups because they might not need that 100% protection, and therefore they might be more inclined to preserve their tourism instead of the trade-off of protecting the locals, right? And you also consider long-term sustainability, high value urban areas, then maybe you care less about tourism. Okay, this live is going to go on till maybe about 8 o'clock, just as we can go through as many topics as possible. So we've done hard engineering, we've done soft engineering, and we've also mentioned the examples and case studies. So let's now move on to the second topic that you guys wanted me to go through, which is wildly river landscapes. So let's have a look at that. Okay, so we're just going down. We scroll down to the topic. I mean, it's alphabetically ordered. So here, river landscapes. Guys, here are all of the subtopics. So put in the chat if you want me to go through all of them in order, or if there's a specific subtopic you want to practice on. Let me know in the chat right now. That would be great. Okay, and whilst I'm waiting for you guys, hello to everybody who's joining. The best structure for the 8 marker, just think 2 paragraphs and a concluding sentence. With your 2 paragraphs, you just want your point. Okay, for example, if it's comparing soft and hard engineering strategies, you can say this paragraph is saying that soft engineering is stronger, and then you want to analyze within that paragraph, and you want to say soft engineering is stronger because of is a better way because it's cheaper, A, B, it's more natural looking, C, it could lead to greater habitats, whatever, and have your evidence. Then your point, your explanation, and your evidence. Then you want another paragraph. So it's basically 2 PEE paragraphs. Okay, I'm seeing a lot of flood risks, any order. Okay, it seems like you guys want me to just go through all of them. So let's just do that, given that 16 of you wanted me to go through this. So we'll start with river profiles. If you guys have any questions, just put them in the chat. I can also answer them as we are going through. Okay, hydrographs also seems to be a key one. River Valley case study. Yep. Okay, we're going to be going through all of these topics. So here are some questions on the river profile. So let's start off by going through them. So let's put them into revision cards so that you guys don't see the answers as we're going through. So far, what do you guys know about river profile? Start blurting them out and thinking about what do we mean by a river profile firstly? Okay, what have you learned in your specification? In this topic, I think there are a bit of differences between what EDEXCEL students learn, especially EDEXCEL A and B, compared to AQA. So make sure you're checking the spec to see whether something applies to you or not. Okay, so let's look at these questions. So one time they asked students, what is meant by a river's long profile? So essentially, there's 2 marks here. It's a 2-sentence answer. Okay, let's put this here. It's a 2-sentence answer. So essentially what you want to say is it's basically a graph or a diagram, and it's showing the change in altitude from the source of the river to the mouth. It's really important that you put that. So the change in the river's altitude from the source to the mouth of the river, and that gives you 1 mark. You have to say, obviously, it's a diagram displaying this. Okay, and your second mark is basically showing what the overall finding is, and the overall finding is that the gradient, okay, the gradient of the river decreases as you're going from the source to the mouth. Okay, and that's a key aspect of the profiles. If you look at how basically rivers start off in the upland areas in the mountains, and then as they go down and as the altitude becomes lower, the gradient also becomes lower as well. Okay, so you can see these 2 points here. Let's look at the next question then. State two features of a river's cross profile in the middle course. Okay, so this is, I think, actually a question from EDEXCEL because it's very specific to their profile. Really good points to say. So firstly, in the middle course of the river's profile, the river channel is widening and deeper. So it's wider and deeper than the upper course. Okay, and what you also want to say is that the river banks are less steep. Okay, so the overall trajectory is less steep. You can say less steep. The mark scheme also tends to accept more gentle. And some people also say other points such as the riverbed being smoother. Okay, and you can also say the V-shaped valley is becoming wider. Okay. Let's now move on to, we answered that question. You can see the points here. The next question, let's move on so that we have some high mark questions. Using a named river, explain how and why the cross profile changes from the upper course to the lower course. So this is talking about the overall effect. So just look at how in-depth these questions are, guys. It goes through literally every part of the spec. So it clearly is really good. Okay, so using this named example, firstly, we want to have a named river identified. So it depends on, of course, what you studied and what case study or example you memorized. So I'm going to be talking about the River Rhine, which is the Europe's major river, basically. Okay, in terms of length, it is 1,320 kilometers long. Okay, so we want to talk about how the cross profile is changing over time. So literally you can split this question up into the upper course, the upper course and the lower course. And for those of you who don't study rivers, and that's not your choice, that's okay. We will be moving on to another topic in very shortly. Okay. I agree. I actually believe that coasts are a better topic than rivers, but coasts just seem more like vacational, don't they? So let's have a look. In terms of the upper course of the river, well, the upper course, you need to say things like it's more narrow, it's V-shaped, and it has steeper banks. Okay, but of course you don't want, the examiners don't want you to just list the things, they want you to apply it to the case study or the example that you've listed. So in the No Waffle AI answer, it's very specific. It talks about how the upper course is actually found in Switzerland, and the cross profile is very narrow, only 2 to 5 meters wide. Okay, so I'm just going to show you straight here. So it's saying how the cross profile is narrow, and they have near vertical banks, right? So it's literally almost straight cuts down. It's not U-shaped in the slightest, okay? And it actually explains why in the student answer as well. This is because vertical erosion dominates the steep gradient, approximately 50 meters or kilometers, and therefore there is a lot of hydraulic action and abrasion on the riverbed. You don't have to do all of this for a top grade, but it's just showing you what you guys want to be aiming for. Okay, and then for the lower course, you want to say things as it says, such as it's U-shaped or it's more flat-bottomed, for example. And you also want to talk about how they have much more gentler banks. Okay, and then again, let's look at how this student has applied it. So in the lower course, which is in the Netherlands near Rotterdam, the cross profile widens dramatically to 400 plus meters. And this occurs because the gradient reduces to, let's use this. This occurs because the gradient reduces to less than 0.1 meter or kilometer, and therefore there is a lot more lateral erosion. So mentioning the different types of erosion is a really good piece of content to know. Okay, the river then meanders. It's more likely to meander at the lower parts of the river, and that then creates, keyword here, a wide floodplain. You also have a lot more river discharge increasing as you go down the river or downstream. Okay, that's just extra points. And it just says how overall it just reflects this shift in the balance of erosional processes from the steeper gradient to and the vertical erosion to the lateral erosion and the more deposition. Basically, the river is losing energy as it goes through. Okay, let's get rid of that. Let's now move on to the next question. Okay, and actually, let's just go through some examiner insights. I think it's important to do that, and then we'll go through the next river question. So it says here, one mistake is students often confuse the long profile with the long section, right? Students draw a river flowing horizontally from left to right. It's not completely flat, guys. The whole purpose is that there is a gradient going down. Okay, it's showing the altitude loss over distance. So it always must show height on the y-axis and then distance from the source on the x-axis. You must link the cross-profile change to erosional processes. I can see how students easily do that. They forget to explain why the changes are happening. And then finally, forgetting to compare in comparison questions. So if you're talking about, long versus, if you're talking about the upper versus the lower part of the cross profile, or long versus cross profiles, or whatever you're talking about, you need to have comparative language. This is what the report said last year as well. Students really lacked saying things like in contrast or however. Okay, so let's now continue. Let's go back to the top and see what other subtopics there are in rivers. So a lot of you guys said you wanted to just go through all of them. So let's now work through the erosional processes, and then we'll discuss the landforms of erosion, then the landforms of deposition, and some case studies as well. I hope you guys are finding this live helpful in some way. I'm trying to make it as useful as possible. Okay, I'm just going to check back on here. So river landscape seems to be quite high, so we will go over that. Some people want to go through hot deserts after this, so that's fine. I think this is a better approach to going through the topics rather than going from the beginning to the end, because obviously people tend to, cover the first couple of topics and then stop covering the rest. So, okay. So 2023, it was, okay, let's convert these to revision cards and then work through them. But yeah, it seems like much better of a strategy to do this approach. Okay, so let's have a look. The first question was asked in 2023 to define the term hydraulic action as a fluvial erosion process. So you can see some higher level language to maybe put the student off their confidence, make them feel a bit scared. So what would you put in this answer? Give me a second. Okay, so let's have a look. Hydraulic action. Okay, given that this is 2 marks, you don't want to put too much information. So clearly it's just the force or power of water breaking down rock. Okay, and as it breaks down rock, water then enters the cracks and weakens and breaks the rock apart. or weakens them. So it's different to freeze-thaw erosion, because freezing, if it was to freeze, and students often make this mistake, is that the water, if you check No Waffle GCSE, that's the app that I'm using. So a key problem with this is that students often confuse it with freeze-thaw, which is the idea that water enters the cracks, it then expands because water expands when it freezes, and then because it's expanding, it causes the rocks to move apart. That is not what hydraulic action is. It's simply the movement of the liquid form of water. Okay, so it's really important to understand that. Okay, so let's just check if that was what was said. Yes, exactly the mark scheme. I hope you guys are impressed about like my level of being able to remember this after so many years. Anyway, let's go on the next one. Explain how attrition changes sediment as it moves downstream. Okay, so let's have a look. So attrition, right? So what is attrition? Well, remember, it's one of the 4 processes that takes place in terms of river erosion. Essentially, what happens is firstly, particles collide with each other. Then the particles break into smaller pieces. Okay, and then the sediment basically becomes rounder and smoother over time. Now, you've got to make it clear that you're not talking about this as an immediate effect. It's over time that you have the smoother or rounder pieces of sediment. Exactly. Sediment sizes decreases, but of course, if you have to stretch it out to 3 marks, that's kind of how you would discuss it. So you can basically say how, as the sediment is transported downstream by the river, the particles are colliding and bumping into each other. These collisions then cause the angular sediment to break into smaller pieces over time, and also not just over time, guys, over distance, right? Because obviously the river profile has varying levels of energy at different stages. So over both time and distance, you then form the smoother, rounder sediment as opposed to the rougher material. So it eventually becomes a very fine silt. Okay. And yes, that is the answer. So let's now look. Explain how abrasion and solution work together to erode a river channel. So notice how the exam questions are pretty much just directly talking about areas of the spec. That's why I like geography, because I think it's very honest in the way that it assesses you compared to like the sciences where it's very applied. Okay, so let's have a look at this. Explain how abrasion and solution work together to erode a river channel. Okay, so this is 2 different river erosion processes. The first is abrasion. So abrasion is basically the idea that sediment particles scrape away at the river bed and the river banks. Okay, that's the erosion that's taking place there. And then if we were to define solution, well, solution always gets confused for some reason by students with the chemical process, but it's basically the idea that water dissolves the soluble rocks, for example, chalks or limestone, over time. Talking about geography, I love how it's David Attenborough. It was David Attenborough's 100th birthday, so I think that's a nice little geography tribute. Okay, so how do these 2 work together? That's the exam question. Okay, and so the question is, the answer would be the 2 processes work simultaneously, right? You need to basically show the examiner that you understand all of these processes are happening all at once, okay, simultaneously, and they deepen and widen the river valley. So that's the effect. Now, if you wanted to use an example, you could as well. For example, rivers flowing through the Cotswold where they have limestone, then solution is particularly effective because obviously the bedrock is very soluble, and abrasion would be more applicable where you've got a really large riverbed, for example. I haven't gone over hot climates yet. Thank you so much to the mods who are helping answer some of the questions in the chat. I appreciate it. So let's look at what we could put. Okay, so notice this. I didn't mention this point. The effect is enhanced in soluble rock types, okay, or high discharge conditions. So that's important. If there's more soluble rock, then both of the effects are going to be higher as well. Okay. Use a named river and explain how traction and saltation transport sediment in different ways. This is a 6 marker, right? Lots of marks here. We are going to look at the river landmarks after, the river, is that what it's called? River landmarks after this question. Okay. This is question and answer, but sometimes in the chat, I can't see the questions because there's so many of you. So do bear with me. I'm sorry about if that happens. Okay, so how would we answer this? Well, let's firstly think about a named river. I'm going to be talking about the River Tees in County Durham. Notice how I'm trying to give you guys loads of different case studies and examples, exposure, because I want you to, if you don't have any examples, this would be helpful. I also have a video in GCSE Geography where I go through all of the case studies for paper 1 and then also paper 2. So check that out as well. So the River Tees in County Durham, okay? And why am I using this example? Because it actually demonstrates both traction and saltation. So it has both transportation methods. Okay. So let's begin. Let's begin with how traction exists. So when we're talking about traction, firstly, let's define it. It's basically the idea that larger sediment rolls along the bed. Because it's heavy, so it doesn't get lifted. Okay, and then what is the kind of effect of this? Well, in River Tees, like the application, during very high energy conditions, in the upper course, traction moves the large material. So notice how traction requires a large amount of energy because the material is very heavy when we're thinking about traction, right? It's the heaviest material at the bottom. So during the high energy courses of the river, which naturally, as we spoke about with river profile, are going to be the steeper parts of the river, right? Near the source, which actually is true for River Tees. Near the source, high energy conditions actually leads to a lot of the boulders and cobbles rolling along the side of the riverbed. Okay, and that's how you apply it. Let's talk about the next one then. But what I do want to say is when it comes to these heavy boulders, in really high energy conditions, it also has the potential to really increase the velocity. So if there is a high level of energy, then it increases the velocity because of kinetic energy, you should know from physics, and so it will move faster. So the rate at which it moves is also something to consider. Now, the second process is saltation. Okay, so saltation exists in the River Tees because that's saltation. Firstly, let me define it as smaller particles bouncing along the riverbed. Okay, and then let's talk about the direct effect to the River Tees. Well, the effect then is that it's carrying the medium-sized sediment, and so the particles are lifted off the bed because of this turbulence, and they bounce through the water column for short distances. Okay, so in the River Tees, there is this continuous bouncing of the medium-sized sediment which is caused by turbulence. So maybe when the river is changing course or things like that, right? Where it's maybe there's a particularly a high gradient. Okay, and that's how we've applied it. And a key examiner tip here is that some examiners who were ultra strict, and I'm sorry to say this, but they required you to actually mention the names and measurements in terms of the gradient, right? So in this case, the river Tees, during traction, they have had a very steep gradient. They would want you to maybe name that. That's only some examiners, though. I can't imagine they would ask you to have the exact numbers memorized. But in your examples, try and think about, okay, what's a number that is relevant here? Okay, let's have a look at the mark scheme. Okay, so you can talk about, we defined both of the methods and how they occur in high energy versus medium energy, the named river, the specific location, and a little bit of detail talking about it. Okay, let's move on to the next part of rivers. So now we're going to look at river landforms of erosion, interlocking spurs, waterfalls, and gorges. We'll also look at meanders and oxbow lakes, and then we'll look at landforms of deposition. Remember, if you want me to cover a specific topic, just put your answers in the poll, and then I will do that. After river landscapes, we're going to look at hot deserts and then weather hazards. It is absolutely possible to make last-minute grade improvements. I don't care what anybody says. It's all about how you use your time. It's all about focus, and that's why my No Waffle AI site was created with the goal of trying to help students in the last few hours and days. Okay, I'm just adding these questions to the revision cards. You can see it pulls out exam question, and not only is it useful to just know the topical questions, but you can also see how relevant it is, right? This was asked in 2019, 2022, 23. So this is something that clearly is constantly asked about. And it also has the predicted questions and some examiner's insights, which we can look at. So I'm sharing some of these with you guys here. Of course, if you want access to the whole thing, like so far we've only looked at 2 topics, I do this for all of my subjects. This is how useful it is. So definitely take a look. Okay, let's have a look at interlocking spurs and how they form in a river valley. Okay. So bear with me. I'm always trying to just watch out for the chat and make sure I'm answering any burning urgent questions. There is going to be an opportunity at the end of the live where I will be going through all of the questions that you guys might have. Okay, so let's have a look at the first question, which is about interlocking spurs and how they form in a river valley. Okay, so there's key mark scheme points you must mention when we're talking about interlocking spurs. So firstly, the fact that we need to consider the river profile, right? We need to consider which, if we're using an example such as the River Wharfe in Yorkshire, then you need to talk about which course of the river. So in this case, we're talking about the upper course. I'm using this as an example. You don't need to mention an example here. So firstly, breaking it down, you've got the river, and the river erodes laterally. Okay, and the river erodes laterally, i.e. sideways, as it flows downhill. So you have to show the examiner that it increasingly begins to flow and erode laterally as it moves downhill. The reason why is because rivers cannot erode vertically fast enough to create a wide valley floor. So rivers cannot erode vertically fast enough, because they don't have enough energy because you're going downhill, and so eventually at the bottom you run out of energy, but B, because also if you are increasing your width, it's harder to increase the depth at the same time uniformly across the whole river, right? So it's not enough to create a wide valley floor. And And then as a result of all of this, the river then winds around hard rock, creating the appearance of spurs on alternate sides. So creating the appearance of spurs on alternate sides. Okay, and basically as you travel downstream, the spurs appear to interlock when viewed from certain angles. Okay, so I'm going to talk about my example then. So my example is the upper course of the River Wharfe in Yorkshire. Essentially, the river winds around bands of resistant milestone grit. And because the river is eroding laterally, because you've got the limited vertical erosion by the hard rock, this causes the valley to remain narrow and V-shaped. The river then meanders around the obstacles, and from certain viewpoints, you get these ridges, and they seem to interlock. And these interlocking spurs are visible near Bolton, so at the north of Yorkshire, where you've got the river carving steep, winding paths through the Pennines. Okay, so that's an example of me applying it to a case study. Here are the key mark scheme points all typed up for you guys. Let's now look at the next question. One of my favorite questions, which is explain the formation of a waterfall using a named example. Okay. So essentially, you want to just break it down into multiple points. You start off with your hard rock. And your hard rock, or your more resistant rock, right? Your more resistant rock overlies softer rock. Okay, so you've got the harder rock and then you've got the softer rock beneath it. And so this softer rock beneath it is eroded faster, okay, is eroded faster. And you want to talk about the two specific reasons. It's either hydraulic action or abrasion that causes this. And as a result of this, this creates what we call a step or overhang. Okay, and this overhang eventually, and the overhang, by the way, is the hard rock that's above it. This overhang eventually, when gravity eventually starts, works its final magic, it becomes unsupported and collapses. So the hard rock becomes unsupported and collapses. Okay, and so this process, you must put, guys, in your answer, this process repeats, right? It doesn't just stop there when you get that waterfall, it keeps going, and over like thousands of years, your waterfall ends up retreating further and further and further. So how you could apply this if you were asked about a case study, you could say, there's a very high force waterfall on the River Tees, which we mentioned, and this essentially has formed because the river flows over the Wine Sill, which is this really hard igneous rock, and it sits above this softer sandstone. So the softer sandstone is essentially eroded rapidly by hydraulic action, the force of the falling water, okay, and the abrasion, the rocks hitting the riverbed, and this then creates an undercut beneath the hard rock. The undercut then leads to the overhang, and then it becomes unsupported and falls. Okay, hopefully that makes sense. A diagram. Okay, a diagram. So you've got your hard rock, your soft rock, right? your soft rock is getting eroded via like abrasion. And also, like, we're assuming that a river is flowing. So if a river is flowing in this direction, the river's also hitting into the soft rock, and via hydraulic action, you eventually get it such that the hard rock looks like this, and then the soft rock looks like that. And eventually, this hard rock is just going to fall completely down. That was a terrible diagram, but I'm just trying to show you how it works. Okay, so looking at the mark scheme then, those are the points. And essentially, there is a drop of 21 meters if you wanted to talk about the River Tees example that I just mentioned. Let's now move on to the next one, which is explain how a gorge is formed and how it may develop over time. Okay, so guys, by the way, this platform that I'm using, if you are new, is called No Waffle AI. Take a look at it. It's just £1.25, and I go through this for all of the subjects, so you guys are saved, because I don't know why they just don't do topical questions with subjects like geography. Okay, let's have a look at a gorge. Okay, and explain how a gorge is formed and how it may develop over time. So we start off with a waterfall. So this kind of links to the previous answer, right? We start off with a waterfall where, you know, we kind of have that same, the points that we already mentioned, you guys are going to have to repeat that. Okay, that the harder rock overlies the softer rock is eroded more quickly or at a faster rate than the harder rock. The waterfall then retreats upstream. So let's continue that answer to the waterfall then retreats upstream, because this process is continuous, it doesn't just stop. And so if you think about it, it's kind of a dangerous process, right? When the rock just collapses and it constantly erodes. And essentially what happens is vertical erosion becomes dominant as the river gradient decreases. Okay, so what does this mean? Well, it's basically saying that the erosion is becoming more significant as the river gradient is decreasing. So what then happens is the harder rock remains high and steep on either side, and the gorge deepens. So I'll do a diagram if it helps to explain this. So the harder rock walls remain high and steep on either side, okay, and the gorge then deepens and lengthens as the waterfall retreats upstream over geological time. So I'll find a diagram that explains this a little bit better. So that's showing the waterfall, and then this is a good diagram. So here, you can see here that the waterfall is retreating. Okay, this was the former position of the waterfall. The waterfall is then retreating, and you get this undercutting. And eventually the gorge is created by the retreating upstream. So it's literally the after effect of the waterfall going out. So what's left? Yeah, what you get that's remaining. Okay, let's now move on to the, well, let's now check if that answer was correct. Okay, a key term to mention actually is geological time. So geological time is basically thousands of years. It's accounting for the fact that geographic processes take a lot longer than like normal processes to happen. Vertical erosion becomes dominant. Yeah, so all of those points, as we mentioned. And yes, you can use the example of the Winnets Pass in Derbyshire. So you can say how it's essentially formed when the river Winnets erodes through the limestone, which is the hard rock, and the shale, which is the soft rock, during and after glaciation. So if you study glaciers, it also links to that as well. Okay, so we've discussed the three main landforms there. Let's talk about the landforms of both erosion and deposition, and then we'll talk about deposition. Let me just check on the poll. So we still want to do river landscapes, fine, and then hot deserts. Okay. Okay. So this is going to be going on till about maybe 8 or 8:30 p.m. at the latest. I would recommend you guys just get the platform yourself and you're able to do it and explain it to yourself at a time that works better for you. But also understand that some of you guys like me talking through the stuff. So firstly, define the term meander. Let's go through this. So remember, these are erosional and depositional landforms. Okay. So define the term meander. Well, essentially, it is a bend or curve in the river, and it forms and it develops in the middle or lower course of the river. If anybody can answer why it develops in the middle or lower course of the river and not the upper course, then make sure you can try and do that on the chat. It's a good thing to check out. Okay, and yes, that is the mark scheme. Next, explain how meanders actually form in a river. Okay, so let's do that. Oh, I'm no longer sharing my screen. 1 second. Okay, so explain how meanders form in a river. This is applicable for EDEXCEL and AQA, as I've said. I'm not able to cover every single exam board. I'm so sorry for those of you who study OCR, but my AI platform does do EDICAS. So if you study EDICAS geography, maybe check that out. So explain how meanders form in a river. Okay. So this was actually asked in 2022, so relatively recently. Actually saying that was 4 years ago, wasn't it? So the key points are the idea that rivers don't flow in a straight line because of bedrock and because of obstacles. So you need to firstly address why rivers don't flow in a straight line. And the reason is because of bedrock and obstacles. And rivers are, they're going to take the path of least resistance. So they're not going to have to do that. Instead, what's going to happen is there's going to be a faster flow of water on the outer bend because of erosion and lateral erosion. So the faster flow on the outer end because of lateral erosion. And then on the inner side, the inner bend, there's going to be a much slower flow of water. Okay, and that's going to cause deposition. And this makes sense, right? Like if you're thinking about a pathway, it kind of just makes intuitive sense. Like say we're talking about the water here and we're talking about this bend. You can imagine that the water that's going here has a smaller distance to travel. So it's going to move relatively fine. It's kind of like when you're running, I don't know if you guys have done sports day where you run like around the tracks. But if you have to run on the outer side, that's going to take longer. And it's also going to mean you bash into everybody else. So that's why it takes longer on the outer bend. And therefore the outer bend, has to have higher energy. And because there's higher energy, it actually starts to erode the things, the kind of the wall, right? The bedrock and the obstacles. And so as a result, the bend becomes more exaggerated over time. Okay, and then we can talk about how as soon as there is a slight variation in the riverbed, the water is going to flow faster on the outer bend because of the centrifugal force. Okay, and this faster flowing water has greater erosional power. It then undercuts the outer bank through lateral erosion. That also sometimes creates a cliff because so on this side, you're more likely to have a cliff because it's just sloping, and you get sometimes a slip off slope or sometimes even a river beach. I don't know if you guys have heard of that concept. Okay, and for this question, candidates often mentioned erosion, but they failed to specify lateral erosion. So make sure you mention lateral erosion in your answers. Okay, so look, that is the answer there. Let's now look at the next question where it's asking you to give a named example and to explain the formation of an oxbow lake. Now, again, this is linked to meanders. It's basically kind of what happens later down in the process. Okay, so an oxbow lake, I mean, we've got to have our example as well. So we've got to give whatever thing you've memorized. For example, I'm going to talk about the River Severn in Wales. Okay, so the River Severn in Wales provides a very clear example of oxbow lake formation. So an oxbow lake is a crescent-shaped lake formed when a meander is cut off from the main river channel. I'm going to just copy and paste that because it's easier to have typed. Okay, so it's a crescent-shaped lake formed when a meander is cut off from the main river channel. Okay, so on the River Severn's meanders in mid Wales, you talk about the points that we kind of just mentioned about the reason why there is a meander in the first place, and like how the outer end has more lateral erosion compared to the inner end. You've got the faster flowing water happening at the bends, at the outer bends. But of course, you want to apply it to the context or to the example. So you're going to say the faster flowing water in the River Severn in the lower parts, in the lower course of the river. And so you also have simultaneously deposition on the inner bend, okay? And essentially you get the narrowing of the meander neck, which is the land basically separating the strip of land between the two sides of the bed. Basically, it's the idea that eventually rivers are just going to go like that. Like what? There's no reason why they would go all the way around. So over time, the rivers go like that and it cuts off the meander. So essentially, rivers, again, take the least path of resistance. And the reason why is because the deposition occurs on the inner bend. Okay, let me try and get a better diagram for you guys here. So this is showing you the key aspect, which is the sediment deposits. So you can see here that the sediment deposits are happening on the inner bend. And so eventually what's going to happen is the river is just going to make a new channel. And you can see the two curves are getting closer together. And then the sediment starts depositing over there. And so you get a new channel. Okay, so how you would explain this a little bit better is you would say maybe, as you can see in the answer, you've got the faster flowing water that has greater erosion power. It undercuts the outer bank, and the inner bend, the water flows slowly. There's a deposition of sediment that creates a slip-off slope. Over time, the bend becomes progressively more pronounced, and as a result, you then form rivers taking the shorter course. The meander gets isolated and the river breaks the neck during often flood conditions or moments of high discharge of water. Okay, I'm not quite sure why people are talking about nerve cells in the chat, but anyway. Okay, this is a good question. Actually, no, we kind of answered that as well. To what extent do you agree that oxbow lakes are always formed by a rapid river erosion? So let's just look at the mark scheme. So in this point, you need to form an opinion. So you can say, oh, I partly agree. Erosion is important, but the formation is gradual, right? It's not this rapid river erosion. It still takes place over geological time, but the deposition of the inner bend is equally critical. It's not just the erosion that's taking place. The meander neck that narrows is a gradual process over months and years. The breakthrough occurs also during specific conditions, right? It's not like it's constant erosion in terms of the breakthrough. It has to happen when there's an overwhelming of the flood barriers. There's a flood vents or high discharge. Okay, it's not, as we said, continuous erosion. And then you would talk about an example, and you can also show a counter argument. Okay, so we have got some landforms to finish. We've still got levees, floodplains, and estuaries for deposition. We're going to go over that and just checking this again. Then we're going to look at weather hazards and hot deserts. I wonder how long has this live stream been going on for, like an hour and 15 maybe? Okay, so we have pulled questions on it. Okay, it has been also asked about a lot in recent years. So whilst we're adding these questions to revision cards, let's talk about some examiner insights that we've gotten. So one mistake that students make in this topic is they confuse levee formation with flood management. Okay, now remember, the levees are human-built defenses. They're not like the artificial levees, right? They're not the natural levees that are formed by deposition. Okay, so make sure you always clarify which one you're talking about and not confuse it with flood management. Another mistake is that students also not explain why the sediment size varies across a floodplain, okay, why the different size sediment is deposited where it is, okay, and it's basically because of physics, right? If you think about the weight, as the water spreads onto the floodplain, the velocity is going to drop, okay, and the heavier material can no longer be carried. They are taking up the most energy, so they're then going to settle first, and then the lighter material travels further before it ends up being deposited. And that's why the distance relates to energy loss. And the final mistake students make in this subtopic is that they describe an estuary as where fresh and salt water mix. Now, this is a little bit incomplete because you need to talk about the depositional processes and the landform development, right? It's the idea that because the velocity decreases at the river mouth because of tidal backflow and friction, it then allows the fine sediment to flocate and settle, building mudflats and salt marshes over time. Again, we'll talk about this more specifically. Okay, we are going to keep going on more topics. We will do a booklet at the end, don't worry. That's one of the, what's it called? The key core memories of the previous year's live streams. I used to do them a lot. Okay. So let's go through these 6 past paper question cards. I haven't been adding them to my subject deck, but if you add it to the subject deck, then you can look through them and it will save all of your progress. So if you get No Waffle AI, only £1.25, guys, then it's definitely something worth adding. And I know you guys might think, okay, how is this going to benefit me? I've got my geography paper 1 exam tomorrow. Well, that's why I cover 10 GCSEs. It's supposed to help you across the next 6 weeks. You're going to get 6 weeks of use out of such a minimal spend. So ask your parents, guys. It's worth it. And you get to support me, your favorite YouTuber. Okay, or your favorite GCSE YouTuber. Let's leave it at that. So firstly, explain how levees form as a result of river flooding. So the water is going to spread across the floodplain. And as it does so, The coarser sediment, such as the sand and the gravel, are deposited closer to the riverbank because it is heavier, as we just said. Okay, and then the finer sediment, like the clay and the silt, are going to travel further. Okay, and as it travels further, it then settles a lot further from the river, so further along the floodplain. Okay, and as a result, over repeated floods, the coarser material builds up along the bank, and that then creates a natural ridge, right? A levee, and we call that ridge a levee. So over multiple floods, which obviously takes a long time, although climate change is exacerbating this, over multiple floods, the coarse material builds up, creating this sort of natural ridge. And in this natural ridge, we call that a levee, and it's basically a bit of sediment that's higher than the surrounding floodplain. Okay, and if you wanted to talk about an example of this, you can talk about the Mississippi River in the United States. They have natural levees up to 5 meters high, and that has been formed because of repeated flooding. So let's take a look at the mark scheme. Yeah, pretty much correct. Okay, as the water spreads out, the friction slows it down. So it's not just about velocity, also you can mention friction. So there are two energy processes there. Let's move on to the next one, which is state two features of a floodplain. Notice how this is still oddly 3 marks, so they're clearly asking for something beyond just stating. So what you want to say is, firstly, there is a flat and gently sloping land. That's basically what a floodplain is. Okay, and then what you also want to discuss is the fact that it's found on either side of a river or river valley. Okay, and as a result of that, oh, sorry, you can't see my screen. So sorry for that. I was going to do this live for computer science, guys, but I didn't have enough time because I also have Cambridge exams to study for. But I'm so sorry. I was going to do something similar for computer science as well. Sorry to let you guys down on that. But I am going to do 8 weeks of live streams, so definitely follow me, and I'm going to do some more subjects. Like I'm doing about 11 subjects, so check them out. And then what you also want to say is that the area that floods when the river overflows its banks is what you call a floodplain. Okay, let's now move on to the next question. Let's just check the answer. So it says, yep, flat or gently sloping land found on either side. Yep. Okay, explain how an estuary forms. Use a named example. Okay, notice this is also 6 marks, so really consider how we can stretch out our answers. Okay, so for an estuary, I'm going to use the example again of the Severn estuary, so by the River Severn in Wales. Okay, so, and you also want to give a little bit of a fact or a piece of evidence for that. Okay. You can email me by using, we are going to be looking at case studies as well. We're trying to do it whilst we go through the live stream. I've just put my email for any of you who want to email me. Okay, so the Severn estuary, let's start by looking at that. So an estuary, firstly, let's define it. An estuary is essentially where the river meets the sea and tidal influences extend inland. So when a river meets the sea and there's a tidal influence. Okay, and so as a result of this tidal influence, it causes different things to happen. So let's go through it. So at the estuary mouth, the river flow meets the tidal current from the sea. So the river flow meets the tidal currents from the sea. Okay, and then what is the impact of that? Well, the river's velocity decreases as it meets the sea, and so that because there's a lot of friction that increases. It's almost like the river is rushing into the sea. The river's velocity decreases as the friction increases because it's colliding almost with the sea. And as a result, the fine sediment that the river has been carrying all the way till the end finally gets deposited where the river and the seawater meet. Okay, so you guys should know why it's only fine sediment that's left at the end of the river and not the heavier boulders. Okay, and essentially over time, this sediment builds up and that then creates mud flats and salt marshes. Okay. So hopefully that makes sense. And if any of you are unable to access No Waffle AI, just send me an email at nowafflelearning@gmail.com and I will be able to help you guys. I've already lowered it to 50% off just for you Year 11 students, so make sure you check that out. Okay. Let's now check whether this was correct. And also, let's apply it to the example. So the Severn estuary, essentially as the River Severn reaches its mouth, the velocity is decreasing because of the friction and because the wider channel is meeting the tidal currents from the Bristol Channel. And so it's slowing the water down. At that point, the fresh water is meeting the salt water from the sea. And so the fine sediment basically becomes sticky and they clump together and deposit themselves. Okay. And this sediment then settles on the estuary floor, gradually building up and turning into salt marshes. And they actually have a lot of them at Gloucester. So that's something to be aware of. Okay. So I didn't write out the use of the examples, but it's something that's important. Okay. The next question, I don't know what's going on in the chat. It's crazy how when more people watch a live stream, the logic in the chat just goes out the window. I don't know what you guys talk about. Okay. Next, we are talking about, actually, to be fair, we've looked at floodplains, we've looked at levees, so it's probably worth changing tact now. We are now going to go on to another topic, because I know a lot of you guys want me to switch, and not everyone does rivers. So I'm going to go through some UK weather hazards. So if you want to get to it on my platform, and by the way, all what we're doing is just one of my AI features. There's also the predict your grade feature, which you answer 15 questions and it will tell you how you'll do. There's the examiner marking. So if you ever had an 8 marker that you actually want to be analyzed like an actual human, not marking, not an AI marking. And then also last minute brain. What do most students forget about every single subtopic? So check that out. But we're looking for weather hazards. So let's just scroll down to that. P1 means paper 1. Okay, here, and let's look at let's start off with types of UK weather hazards and pull some questions from that. Okay. As I said, I have this resource for every single, 10 of the major GCSEs. So No Waffle AI is something worth investing in. And also, if you buy the long-term access, you get access to A-levels and AS help for your next coming years. Because guess what? No Waffle GCSE is expanding to A-levels as well. Okay, so you can see that it has now pulled all the exam questions ever asked about this specific subtopic. I'm scrolling to the end because we're going to add these questions to revision cards, and we're going to then, because I don't want you guys to see the answers as we're going through, and then we'll be going through them on this Miro whiteboard here. Okay, so that's that. We can see the past paper questions. Let's start off with just basic 2-marker defining the term weather hazard. You also have the ability to add it to your subject deck so you can review it just before the exam hits. Okay, so this is kind of a basic one. It's basically a natural event that poses a threat to people and or property. A threat to people and or property, or sometimes people say like destruction, and it refers to destruction. And you also wanted to mention the fact that, so that's all one point, and then you also want to mention what actually weather hazards constitute. You want to say it's a natural atmospheric event. And this natural atmospheric event, such as heavy rain, snow, ice, floods, well, I mean, it causes floods, but not necessarily inherently floods, strong winds, heat waves. Okay, all of those examples, or drought that poses a threat to, as we mentioned, back to the point of human lives or property, any sort of destruction in that regard. So that was asked in June 2022. Let's check what the mark scheme said. Yeah, natural event poses a threat. It's weird how the mark scheme didn't actually describe the weather aspect of it, but oh well. Sometimes mark schemes are a bit dodgy. Okay, next, explain 2 different types of UK weather hazards. So I'm guessing here you would have to define 2 different types. Of course, there's multiple, as I said, so it depends on what you learnt, but I'm going to go through heavy rain as the first one, because that's something we probably in the UK are all familiar with, unless you're not in the UK right now. So heavy rain occurs when you've got really warm, moist air, and that's forced to rise, okay? And because the warm air is forced to rise over the high ground, okay, what eventually then happens is that it eventually reaches the cold air. And when it collides with the cold air, it then begins to condense. And when massive amounts of this happens, this condensation, this huge condensation, basically leads to rain and heavy amounts of rain. Okay, so that's one. And you can talk about how this possibly leads to flooding, landslides, transport disruption. Think about the possible effects. Why does it constitute being an extreme weather hazard, right? Okay, and another point you can mention is snow and ice, for example. So heavy snow or just extreme snow. That's not something we experience a lot or frequently, but it's essentially the idea that when temperatures drop below 0 degrees Celsius and it's allowed to settle, so it requires a little bit of precipitation. Okay, when it's allowed to settle, then in winter months or at higher altitudes, it can be very dangerous for driving conditions or just in general people. Okay, next, let's have a look at the quick mark scheme for that. Question 3. Using a named UK weather hazard example, explain why it poses a significant threat to the UK. So again, this depends on the example that you have studied. Okay. I'm going to refer to the Somerset levels flooding. It's also useful to remember what year events happened because sometimes they happen more than once. So this happened in January of 2014. Okay, and so the first thing is naming the hazard and identifying it. So in this case, it was the flooding that was caused, and we've also identified the area. Now, why does it pose a significant threat to the UK? Okay, and given this is 6 marks, so you really want to analyze multiple reasons here. So the first point is because of the cause, right? The cause was the heavy rainfall. And the heavy rainfall, which was up to 300 millimeters? Millimeters? Millimeters in winter between 2013 to 14. So that was an unusual amount of rain and precipitation that took place. And because of these record levels, this led to widespread flooding across farmland and villages, including Mulchney. Okay, and we've got to talk about more explicitly in the example, why is it a threat? Well, it is a threat because in this area, there was a very low-lying flat terrain, sometimes even below sea levels. And because of this, it meant that water could not really drain naturally. There was no natural drain that existed. Okay, and as a result, they kind of just they left these 65 square kilometers of area flooded for months. This was major, right? What was the impact? Well, 8,000 people were affected. Livelihoods were destroyed. Agricultural land, this farmland that we spoke about, became waterlogged. And as a result of that, it meant that there was a lot of impact on food security and on the economy because a large proportion of this area contributed agricultural aspects to the GDP, right? And their livelihoods became destroyed. In addition, the evacuation costs costed 100 million, and that was back then. So hopefully you guys can see this almost list or this cumulative reasoning as to why this was a significant risk, okay, that was posed. Okay, really good that you guys are engaging and answering in the chat. That's fantastic. Okay, let's continue. So let's look at the next question. To what extent has UK investment in weather hazard preparation reduced the impact of weather hazards on people? Okay. Okay. So let's have a look at this. Well, UK investment in weather hazard preparation. So we've got to think of the various methods of preparation that has taken place. For example, flood defense schemes. That could be one up point, you could say. Given that it's 8 o'clock as well, guys, what time do you want me to... Depositional processes, we did go through depositional processes as well. We did go over that, like meanders in Oxbow Lakes, they were partial, and then levees, that is a depositional landmark created by the process. Okay. I'm so sorry if my handwriting is messy. That's why I'm also trying to read it as well. Okay, we're going to continue this on for maybe half an hour or however long you guys want me to continue and answer your questions, really. But by 8:30, we will move on to like doing something. I'll try and do the nice handwriting. I'm unable to, because I'm using Restream, so I can't really give people mod roles from here. I have to be on YouTube, and my computer will explode if I open one more tab, so I can't do that. Okay, flood defense schemes. So flood defense schemes often operated by the Environmental Agency in the UK. Okay, and essentially what they do is they try and protect 5 million properties. So really the residential impact here. Okay, and essentially what they do is they try and reduce the impact that floods would have on people. For example, they had flood resilience measures in Hull, and that experienced severe urban flooding in 2007. Like 15,000 properties were flooded. So they were upgraded and improved, and there were improved drainage systems and flood walls. So just think about all the various aspects. Okay, other things that was done was creating early warning systems. So the need to have 48 hours plus notice, which then allows 70% of at-risk population to evacuate safely. Okay, I'm not going to do a night before computer science just because I don't have enough time. Sorry for that, guys. I'm trying to write more clearly, so I hope that helps. And then how do we evaluate this, right? What could we put? Well, there are limitations because there were the February 2020 storms, and they showed that investment can't really fully protect against extreme weather. Like the storm had brought 200 millimeters plus of rainfall in 2 days. Properties were flooded, even despite existing defences in South Yorkshire, for example, costing 10 million. Okay, and so it really clearly shows, in terms of the evaluative aspect, that there is only a limit to how much investment can prevent destruction from taking place. Especially, and you can talk about this, the climate change increasing the severity in terms of the intensity, but also the frequency of these events. Clearly, the UK investment would have to up-level its game significantly for it to work. Okay, so let's look at the mark scheme for this question. Okay, here it just puts some points that evidence that the preparation has reduced impact with named examples. I was giving some stats. Evidence that it hasn't, so counter arguments and using appropriate geological terminology. Oh, Jude. Oh my God, Jude is back. That's crazy. See, I was hoping you would come back actually. Just note this down. You need to be, can you send me an email, please? Because I need to add you to the No Waffle alumni. And everybody who's watching this live now, I'm going to add you guys to the No Waffle alumni for 2026, just so I can hear about how you get on after you graduate from GCSEs. Of course, I remember you, Jude. Okay. So that was some ex-students from previous years, guys. That's the kind of relationships we have. Anyway, let me continue. So the next question we can talk about, use a named example and explain why the heat wave of 2018 poses a significant. Okay, these are just kind of predicted questions. They would never ask you something like use a named example and then tell you an example to use. It will be a bit different from that. So we'll look at some more questions. Okay, what was the next topics you guys wanted me to go across? So we've done weather hazards. You guys want me to go over climate change effects and responses. So let's select that. Okay, so just go through. That's the first topic, easy for us. And let's just start with the first topic within that. I'll just get my whiteboard ready. I don't know what you're doing now, actually. How are you? Yep, I'm doing a night before every single GCSE. An alumni is an ex-student, yep. Yeah, so okay, interesting. See, Jude can attest to how good I've been in terms of my YouTube videos. We've up-leveled the game, Jude. I now have an AI platform that I made, so I hope you're proud of me. And I would love to know what you are up to as well. Okay, so we're converting these exam questions to revision cards. That's another aspect of No Waffle AI. It does that in relatively short time. And it also does all of these other things, like shows the difference between your current grade and what a top grade response is and what you're likely to forget in the exam. Thank you. Okay, so let's answer this question. Explain how climate change is leading to a rising of sea levels. I feel like this is kind of self-explanatory, but we'll go through it anyway, just because you need to have the correct terminology here. So what you would want to answer, explain how climate change is leading to rising sea levels. So firstly, you want to talk about how sea ice or sea glaciers are melting. Okay. Then because of that, the loss of ice is leads to obviously the water levels rising. Well, it has two effects, right? The first effect is water levels rising. And then the second effect is because there's a loss of ice, there's a lack of reflection of heat, right? Because a lot of the ice, because it's white, it reflects the heat back into the atmosphere. Now, because of that, like the answers in the chat, so because of that, it means that the water absorbs the heat, because water absorbs more heat than ice does. Now, because water absorbs more heat, it then means that the water gets warmer. Global sea temperatures, you need to mention, rise. Okay, and another point you could possibly make if you're a bit more advanced is the idea of thermal expansion of water as the temperature increases as well. So because the temperature increases, this leads to thermal expansion. Like the water literally becomes larger in terms of their particle size, they're more energetic. And so that is a consequence of that. Okay, let's look at a model answer then. So you can talk about how glaciers in Greenland and the Antarctic Peninsula, they melt because of the rising temperatures, and that means that the rate of the melting exceeds the rate of snowfall accumulation. That then adds water to the oceans, raising the sea levels, and as the ocean water warms, it expands thermally, further raising sea levels. So it's really bad because there's so many multiple, like it's cumulative in the way that it causes the sea levels to rise. So that's a summarized argument for you. Next, explain how rising temperatures may lead to an extinction of a species. So this is a useful question because I feel like people don't revise climate change necessarily in that way. Well, some people, so, okay, anyway, so this question, rising temperatures may lead to extinction of species. So what you want to talk about is, firstly, habitat changes and how habitats are changing faster than species can adapt. Okay, and because of this, because the habitats are changing, as a result, what happens is the species are unable to get sufficient food, right? Because they aren't able to adapt, they are essentially disadvantaged. And given that they are disadvantaged for some reason or another, whether it's the higher temperatures or the heat just overwhelming them, and therefore they have too much fur for that temperature, and so they are more tired and they waste energy or whatever, any reason, it means that they are unable to get access to food because they're no longer as well adapted. And so you can use a named example. So you can talk about how polar bears, for example, are not able to get access to sufficient food because the ice is melting and they depend on the sea ice to hunt seals. Okay, so that would be a useful example to use and draw upon. That's the mark scheme there. We can also talk about explain two ways that climate change is causing increasing food insecurity. So this is a little bit of a, okay, I'm not going to answer that because that is a topic for paper 2, food insecurity, if you study food. Let's talk about, let's do this one, which is explain how extreme weather events linked to climate change impact communities. So what is the impact on communities? I love always talking about Indigenous communities as well because they should be represented in our answers. Okay, so explain how extreme weather events linked to climate change impact communities. So let's start. Firstly, we want to say what is meant by an extreme weather event. Like we need to define what is meant by that. So we can say an extreme weather event is defined as events that are caused by climate change. Oh, no, not necessarily. So an extreme weather event is a weather event which, based on the geographic and atmospheric natural conditions, an event that surpasses typical magnitude. For example, you can talk about increased severity or increased frequency. Okay. So you can have extreme weather events that are natural in an area, but if it's extreme, it typically is unusual for that area. So how does this link to climate change's impact on communities? So our first point is that there is a physical impact through flooding and damage, right? And that could be economical as well. Because of the costs associated with that. Another thing to mention, which is a bit of human geography, is the fact that because it impacts people disproportionately, right? It impacts those who maybe are on islands or those who are on like lower floodplains. Because of it impacting those people, it actually increases insecurity globally, because those people tend to also be the poorer communities. For example, in Bangladesh, the persistent flooding really negatively impacts the GDP per capita. Another impact that you could discuss is the social impact. So you can think about, I guess we've kind of discussed this in that people are, there's increased not insecurity, inequality. The increased inequality, but there's also displacement from their homes. And if people are displaced from their homes, they're then relocated. That is a huge social change. Also, the destruction leads to, hospitals, services, schools shutting down. And that could really lead to stunted growth. For example, often in countries like the Philippines, where there are a huge amount of natural disasters, the countries have to actually make everybody in a specific year group restart their year. And so that's why there's often an age difference, okay? Between like UK students and other students, because they literally get held back, unfortunately, because of that. But also, if you think about extreme weather events in the Western world, like the Hurricane Harvey that hit Texas in 2017, 30,000 people from that event were displaced from their homes and 68 deaths were recorded. So it also impacts wealthier nations as well. It's just that the impacts are magnified for poorer areas. Okay, and we are now going to move on to the next subtopic, exam questions. Let's discuss mitigation strategies for climate change. Let's refresh ourselves on this. So we've done river landscapes. We've done a lot about rivers. We have done a bit of climate change we've done weather hazards, and we're now on climate change. We're going to get to hot deserts as well. If you guys have any more suggestions, put it into the poll, please. Unfortunately, I'm not doing a computer science live just because of timing. I don't have enough. Okay, so it's pulled the exam questions now. Let's convert them into revision cards, but let's also go through the examiner insights. So what examiners found with this subtopic is that students were using very vague case study application. They named location, but they didn't provide specific data or a timeline, or any sort of quantifiable outcomes. Okay, for example, instead of just saying Brazil uses renewable energy, you want to put Brazil São Luís solar farm generated 375 megawatts of renewable energy. So that just strengthens your answer. Another thing is people confuse mitigation strategies with adaptation strategies, like flood defenses, drought-resistant crops, when the question is asking for mitigation, right? So you need to know the difference between it. Mitigation is preventing climate change by reducing greenhouse gases. Adaptation is adjusting to the impacts as if it's happening. It's kind of like almost the give up approach, but it's not quite the do nothing approach. And the final one is ignoring the limitations and trade-offs. So students often don't consider making a balanced evaluation. Like, consider the different stakeholders, right? Who are we considering in our trade-offs? And also, what are the various constraints of the mitigation strategies? For example, students often say renewable energy reduces emissions immediately, but you could also add that it requires the high upfront capital investment and the backup systems for grid stability. This is a huge amount of sunk costs, and it takes a lot to get that going and set that up in specific countries. Okay, let's now go through some of the exam questions available. Okay, make sure you check out No Waffle AI, where you can access all these resources for only £1.25 for every subject, guys. Okay, so let's look at the first question. Explain using a named example how renewable energy can be used to reduce carbon emissions. Okay, so let's have a look at this. Renewable energy now. So this was asked about in 2023, so not too long ago. The first thing you want to do is identify the relevant renewable energy source. So in this case, I'm going to be talking about wind. Wind is really important in the UK because the UK is one of the windiest regions in the world, if you didn't know that. So keep that in mind. So in this case, we're going to talk about wind power, or often referred to as wind farms. And we obviously need to speak about a named example. So I'm going to talk about the wind farms that exist in Denmark. Okay, so firstly, how does the technology work? So wind farms essentially generate electricity without burning fossil fuels, or in general, that's the definition of renewable energy. Okay, and then wind power does that specifically via having the turbine, which is obviously controlled by wind movements. So you've got wind movements, which impacts the large turbines, and these large turbines then work to power the generators, and the generators often give rise to electricity, okay, or electrical energy. And how can it be used to reduce carbon emissions? Well, essentially, Denmark is really effective because they generate, especially over the North Sea, they generate 80% of the country's electricity from renewable sources. So Denmark is really good. And each turbine can generate 2 to 3 megawatts of power. Okay, and it avoids approximately 2,000 tons of carbon dioxide emissions. So there are no carbon dioxide emissions involved here. Okay. Now, if this question was evaluate, which I think it often would be if it was 6 marks, then you obviously have to talk about the disadvantages, the shortfalls, in which case you can mention how with windfalls, it's difficult. With wind farms, it's difficult because they generate a smaller amount of electricity compared to using fossil fuels. So you would therefore need very large open spaces, and you'd have to dedicate open spaces, often sea spaces as well. Like you can't obviously have boats going across them and such. And therefore, there is a trade-off involved. Also, initial manufacturing and installation has carbon cost if you think about it. Like the creation of the turbines itself does have carbon costs. So it's not completely carbon free, but it might be carbon neutral. Okay, so that is answering that question. Let's now move on to international agreements and how they help to reduce climate change. This is very important in EDEXCEL. Okay, so two ways that international agreements help to reduce climate change. So one point, so this was asked in 2022 in the June paper. So it was said one strategy we could say is Paris Agreement of 2015. Okay, and the Paris Agreement of 2015 was really important because it required all 195 signatory nations to nationally set determined contributions to reduce greenhouse gas emissions. So it basically forced legislature commitments to the reduction of greenhouse gas emissions. Okay, and therefore it created that accountability and shared responsibility globally. So that's what you would say to develop the point. Okay, and then what you would also want to mention maybe is the Montreal Protocol in Canada. So the Montreal Protocol, which happened in 1987, so a long time ago, okay, they phased out ozone depleting chlorofluorohydrocarbons. I know this from chemistry A level. So they phased out the use of CFCs. And that was really bad because they were depleting the ozone layer. So they were basically chemicals that were used in like hairspray and things like that. And they in Australia were creating a hole in the ozone layer. So it was really good that they acted with immediacy and completely got rid of them. So both of them are important because they create these frameworks that actually bind nations together. Okay. Let's now move on to some more questions. So, oops. So we did that question. We can also do afforestation. So using a named example, explain how afforestation, which is basically the opposite of deforestation, can help mitigate climate change. So essentially really spelling out for the examiner how trees and the planting of trees is useful. I think we might just go through this. So here, name location with context, explanation of carbon sequestering, okay, how the trees absorb carbon dioxide during photosynthesis and they store carbon in their biomass. Quantify data about carbon storage capacity. The scale and extent of the scheme with statistics, because obviously we had to use an example here. So if we go back to the model answer at the top, it should give us an answer, which you can use. Okay, so it says here, for example, the Loss Plateau Afforestation Project in northwestern China has planted over 32 billion trees. Wow, that's insane. Across 32.7 million hectares to combat desertification. Okay, so that links to the deserts topic, and also reduce atmospheric carbon dioxide. Trees absorb the carbon dioxide via photosynthesis. They then store carbon in their biomass. A mature tree then sequesters, which means it basically absorbs 20 to 25 kilograms of carbon dioxide annually. The project has then increased forests cover, and also it has stored an estimated 8 billion tons of carbon benefits, including soil stabilization, reduced flooding, improved air quality. Okay, and it's extended that answer a little bit more because it's a top student answer. Okay, so it's 8:30 now. So we've gone over river landscapes, we've gone over climate change effects, we've gone over UK weather hazards. I would really recommend you guys get my platform, No Waffle AI. It goes through all of the topics, not just for GCSE geography, for 10 different GCSEs, exactly how I've just done it. It's aimed for last minute success. Do you want me to go through anything else? If not, I will end the live here. So just kind of message in the chat because I don't want to waste your guys' time. You need to get enough sleep, etc. So just message in the chat if you want me to cover any remaining topics desperately. So deserts, I'm seeing. Can I go through the case studies? I have a video which really condensed, because I don't want to waste your time talking too much. It really condensedly goes through all the case studies. So watch that video. We are going to do a booklet at the end, don't worry. Hot deserts. Okay, apart from hot deserts, is there anything else you want me to go through? Guys, watch the video for case studies. We already went through soft and hard engineering. Okay. As I said, watch the video on case studies. It's very quick and you can watch it at maybe like 2 times speed if you, it's going to be a lot more efficient for you. Don't worry. Okay, we're going to go over hot deserts and then we're going to do a booklet after about 10 minutes, if that's fine. Okay, so finding hot deserts. And for all the people saying that if you watch this live, you're going to fail, I think the 2 years before you beg to differ, but it's up to you. People often find my lives really helpful. And if you want a live that actually goes through all the content, you can watch the live streams I did 2 years ago. Yeah, I'm honestly trying to help you because I don't make much money off of monetization of them. So, you know, it's really your loss if you choose not to. But I understand everyone has different revision systems. So do what works for you. Hot deserts. Okay, so we're going to go over characteristics first. Okay, you can see all of the subtopics are available at No Waffle GCSE. We are going to do booklet in maybe 10 minutes or so. Okay, so it's pulled the exam question. Sorry, I was just staring at the screen. Okay, let's do some. Oh, sorry. Accidentally pressed the wrong button. Okay, so start thinking about the characteristics of hot deserts and what it means for various things like interdependence and other factors. And whilst we do that, we can go through some of the examiner insights on the common mistakes in this topic. So examiners find that within the hot deserts topic, students often say quite vague information without using data. So drawing upon data is really useful. Like instead of rainfall is low, it is less than 250 millimeters annually. AQA specifically rewards specificity, not so much EDEXCEL. Describing adaptations without expanding on the problems that they solve, right? Like instead of just saying cacti have long roots, you need to mention the reason why they have long roots is because they increase their reach to groundwater sources because of the fact that rainwater is so scarce in the desert environments. Okay, and also some students confuse soil color with soil type. Now, desert soils are light colored because of the low organic matter, not just because of the heat alone. So the color of soil is different to the type of soil and whether it's, you know, fertile or not. Okay, let's look at these questions. So firstly, state 2 characteristics of hot desert climates. Okay. So, I mean, relatively basic. So we can just say, when was this asked? This was asked in 2024. You can say very low annual rainfall. And of course, be specific. So you can say less than 250 millimeters. And your second point is that you also wanted to say very high temperatures. There's a lot, or you could say there's a large temperature range between day and night. Okay, and you can talk about the Sahara Desert, for example. It experiences less than 250 millimeters of annual rainfall, making it extremely arid. Temperatures in locations like Cairo, Egypt, exceed 40 degrees Celsius during the day, but can drop to about 10 degrees Celsius overnight. Okay, so those are the mark scheme points. Next, explain 2 ways in which desert plants are adapted to hot desert climates. Okay. So some points you could possibly make then. Well, I mean, it obviously depends on the ones that you are revising, but you can say cacti as a common example. Cacti have long roots, and the roots spread out near the surface to access groundwater. So cacti. Okay. Another aspect you can say is that cacti have reduced leaves or very small leaves if they do have leaves. Okay, and the effect of that is that, or sometimes they even have spines instead of leaves, and this reduces water loss through transpiration. As you guys should know from bio paper 1 yesterday. Or was that today? Today, sorry. So you can look at how in Arizona, the Sonoran Desert, you've got the saguaro cactus that has an extensive root system that spreads not just deeply, but also horizontally as well. Okay. And so through this system, they have been able to access any rainfall that falls at any point in the year. And also cacti have these very thick, waxy skin instead of these leaves, and that also helps to prevent water loss. Okay, I can see you guys' points on cold environments. I will try to do that as well. Okay, let's just continue answering some of the exam questions here. We've done characteristics pretty much. Let's look at interdependence. And then we'll move on to one more from hot deserts, then we'll look at cold environments as well. Okay, just preparing my screen. So interdependence is basically the idea that the organisms work amongst each other to live, and they not just work amongst each other, they need each other to operate. So if we look at some of the first question, for example, explain 2 adaptations of desert animals to hot desert conditions. Well, one point we could say is that we've got camels. Now, camels have humps. The humps store fat, and that allows them to survive for very long periods without food. Okay, because again, food is scarce. Like if water and rainfall is scarce, then the amount of vegetation is going to be limited. And so when you have very extreme drought conditions, the camels are able to survive. Okay. Secondly, many desert animals like fennec foxes have very large ears. The whole purpose of that is to lose heat quickly to the environment and help them cope with the extreme daytime temperatures, often exceeding 40 degrees Celsius. This is essential because they are nocturnal and they shelter during the day in underground burrows to avoid the intense heat. So clearly they can't handle the heat as much. Guys, please don't be rude to Jude. Jude is the original. You guys have nothing over Jude. Anyway, let's continue. Use a named hot desert and explain how the climate influences the distribution and type of vegetation. This is an interesting question. I actually saw this question also, a similar version of it in EDEXCEL B. So let's have a look at it. Okay. Firstly, let's talk about the named deserts. So I'm going to talk about the Sahara Desert. Okay. And in the Sahara Desert, how is it relevant? Well, it's because of the fact that it experiences very huge variations in climate, and so it's a good example to use. The variations in climate are visible just during the day, as we said, in the night and then in the night and then in the day. But let's first talk about how one climate characteristic that influences the distribution of vegetation is, of course, rainfall. So the Sahara Desert has very low amounts of rainfall, and this very low precipitation means that plants can't survive in open areas. What do I mean by that? Well, if you think about it, vegetation such as drought-resistant plants are the only ones that are able to live. And in addition, these drought-resistant plants are going to concentrate around the water sources. And because they do that, that means there is an intense level of competition around those water sources. And so, you know, there's therefore a very high threshold for plants to exist and live in these areas. So there's a high threshold of competition for these different, vegetations. Okay, another point we can make apart from rainfall, which influences the distribution, is extreme temperatures. And by extreme, I'm talking about mainly the temperature changes and shifts, right? By the way, whenever I draw a triangle, I'm talking about a change. That's what it means. So the temperature range will only be able to favor plants that are going to have an ability to, especially the hot temperatures, it's only going to favor plants that have an ability to preserve water. In their cooling systems, right? So often a way in which plants cool themselves down is through drawing water out of the plant via transpiration. But if you wanted to survive in the desert, you're going to need to have a cooling system which doesn't lead to water exiting the plant, because it's needed, right? It's not just something that should be used to cool the plant down. So that's where waxy cuticle systems are really useful, which again are present in cacti. Okay, and that means that even though the water is moving throughout the plant and cooling it, it is not leaving and exiting the plant. Now, a bit of examiner insight on this is that students tended to describe the climate part of this question and the vegetation part separately. So you have to have the causal link of how the climate is directly impacting distribution. So how does this impact the distribution and type of vegetation? Well, it only allows for a certain adaptation, plant with adaptations to operate. Okay. The next thing that we'll look at is, I mean, I don't think we're going to have much time to go through cold environments, if I'm honest, with enough effort. Sorry, I've lost the hot deserts. So I would recommend, if you want to access the rest of it, you guys are going to just have to buy my thing, because otherwise I'll be here till midnight going through everything. And I don't think that's really possible. We're going to do one last question on desertification, and hopefully talk about an example. Actually, there is a server error. Let me just check this. Okay, and it's more, instead of just desertification, it's also about how you would mitigate and try and reduce desertification. So what strategies can you have? Things like water management, soil management, tree planting. But remember, afforestation can also be counterintuitive if there's a limited amount of water. We are going to do a Blooket. We're just going to do one more question. Guys, it's only £12.50. It's definitely an investment worth doing. I've made it 50% off for you guys, so hopefully you guys will be able to afford it. It's only £1.25 per subject. We are going to do a Blooket after this. I'll write it at the top of the screen so you guys are happy. But of course, I think I might have to do a Kahoot, because I'm not sure if there's a Blooket related to GCSE geography, unless any of you guys want to link one down for me. Okay, so let's do some questions on desertification. Before we do that, just a quick review. Also, my platform tells you some key case studies to memorize at the bottom of the pages. But let's look at some examiner insights and common mistakes. People think that tree planting helps because it reduces soil erosion. No. Acacia trees specifically are planted, and their tree roots also bind the soil together. And that then prevents wind erosion, and it anchors the tree in, because the Saharan desert has a lot of wind conditions, okay? Okay. Now, also drip irrigation systems save water and increase crop yield. That's a common student mistake. It's more that it reduces desertification by allowing the vegetation to establish in marginal land, right? In land where there isn't much fertility already there. And the vegetation then covers and stabilizes the soil, preventing further degradation. Okay, let's have a look at the revision cards. Well, let's just pick one question and go through it. So we kind of already mentioned that, so let's go through this. Explain 2 water management strategies used to reduce desertification. This is a 4-mark question. Let's go. And this is our last question. Okay, so 2 water management strategies used. The first strategy we can say is things like dams, drip irrigation, boreholes, anything like that. So I'm going to mention terracing, and this is used in the Atacama Desert in Peru. Okay, and essentially what this is it allows the slow water runoff on slopes, and that then allows more time for the water to infiltrate and recharge groundwater aquifers. So it's basically elongating the time for water to sit on the slopes, okay? And as a result, that increases soil moisture available for vegetation. It prevents soils from drying and degrading. And then the second strategy is drip irrigation. So I'm just going to paste the model answer here, so it's easier for you guys to read. The second strategy is the drip irrigation system, and that's used a lot in Israel and also generally in the Middle East. And they deliver water directly to the plant roots. So there is no inefficiency in its transfer, right? There's no water that's wasted. So there's minimal evaporation loss. And this then allows farmers to grow vegetation on, as we said, marginal land. Okay, so we are now going to do the booklet. Does anyone want me to go over any more aspects? I don't think I'm going to actually have time, so I would recommend checking out the No Waffle platform. Let me just show you something before we move on. So you can see these are some of the subjects that we offer. Again, it's been designed and tailored for last minute success. So you guys are in the perfect arena for that. You can add some more subjects. We do multiple exam boards here. And often as we go through the live stream season, I'm going to just put most of my content on here so that the paying users can benefit. So definitely check that out. We are going to do the booklet now. Give me 1 second. I'll sort that out. You guys definitely want to mess around. Actually, I'm not going to tell you. I'm not going to say that. Do I have to create an account to do this? Okay. My email is nowafflelearning@gmail.com. Okay, what I'm going to do is I'm going to run the booklet, and if anybody wants to do any more revision, I'll also be here for you guys as well. So, because I understand that not all of you want to just play the game. Okay. I don't know why it's not just signing me in. I'm pretty sure I made an account back in the day when we were doing this on previous live streams. Okay. Is there a limit to the number of people? And also, can I make it GCSE geography related? Let's see. Okay, so there are some GCSE geography ones. I'm going to do the one that's just... Okay, this is a good one. Oh, I'm going to do the basic gold quest. I'm going to be expanding my provision of stuff to A levels as well. So that will be really important to do. That will be for next year. So by the time you guys are in September or October, you will have A level resources for as much as possible. I don't know if there's like a limit to the number of people that can join, given that there's like 200 and something of you. So, and also for the people who still want to revise, just hold on, as we will eventually get to concepts. So for those of you who want to keep studying, we definitely can. I'm just going to let this run in the background for everybody who wants to play. So just give me a second. Give her a second, God. I love that. I love that. I'm not going to tell you what college I study at Cambridge. I don't want to get stalked, guys. I'm not going to tell you my internal, or at least I wouldn't tell an entire group of very responsible year 11s. Is it full? Can no one else join? Okay, I'm going to start another one. Give me 1 sec. And then you guys can join that instead. Okay, there's the other one. I'm going to start the first game. If you didn't manage to join the first game, you can start the second. I don't know why it's not letting me start. What's going on? Oh, wait 1 second. I'm trying to start the Blooker, but it's not letting me start. I don't know why it's not letting me press play. 1 sec. I think some of you are going to have to stop trying to go to the first game. Oh, I can't do 2 at the same time. Okay, you know what? I don't know what's going on. Let's do this again. And for people who don't get into Blooker, you guys can do Kahoot instead. Sorry, I've just kicked you all out. I think because there's so many people that we're going to have to do it a bit differently. So I'll do a Kahoot as well. Okay, not too many people join because otherwise it wouldn't let me start the game. Yeah, I had to start it because there was too many of you. We are going to do some other Kahoots as well. If you didn't manage to join that. What is that music? Okay. And I'll make it, as I said, so that the instructions come on your screen. Show the questions, yep. That's fine. Autoplay will also be on. Oh, we don't want it to automatically start in 14 seconds. How's the other thing going? Okay, people are playing Blooker. Okay, that's the limit. So if you didn't get into that one, you're going to have to join this one. If not, we'll start that game. Oh, sorry. Kahoot does not hold 2,000. It can only hold 44 people for me. So, and it's fine. I can do multiple Kahoots anyway. So that should work. Okay, and for any of you who were unable to join that game, you can join this final game. Well done, Ray, for climbing up high. I mean, logically, there should be about 5 different Kahoots if everybody wanted to play. So, okay, no one can keep joining the previous game because, oh, sorry, I needed to put a timer on that. I'll make it autoplay. Okay, and then if you're unable to join that, you can join this new Kahoot. It's crazy. There's so many of you right now. Okay, Noor is at the top. Okay, Debs is coming up. 9's for Ben is 3rd. Ollie is 4th. Okay, let's go. In this game, let's see who's going to smash the first question. If any of you haven't got into any game, you can join the game that's on screen now. I'll show you guys the leader. Oh, can you not see the leaderboard? That's really annoying. I'll be telling you the leaderboard as well. So it seems Mole is winning one of the games. Noor is winning this another game. DB Darian is winning one game. And then in terms of Blooker, it keeps changing, but Chess seems to be winning. Oh, no. Okay, T seems to be winning. Okay. Leaderboard still the same. Mole is first, Winnie is second, I is third, I Love Winnie is fourth. This might be a bit outdated. T is first in this new game. DB Darren has gone low. Okay, it seems I have to do another Kahoot for those of you who still haven't managed to join. You guys must have some other level of luck if you didn't manage to join the first 5 Kahoots. One, two, three, four. Okay, I'm not actually allowed to host any more Kahoots. It seems I can't do more than 4 at once, so bear with me. Maybe I should upgrade to the premium so that we can do this. Winnie seems to be up at the top. Jack has come up 14 places. Wow. T seems to be at the top with an answer streak of 3. Okay, here's another one if anyone hasn't managed to join any of the games yet. I don't know how many questions the Kahoot is. We're currently doing Kahoots just for a little bit of downtime, but honestly, we're going to have to end it at like maybe 15 questions time, just because I've got some work to do as well. I mean, I guess I could do work whilst hosting these games. I just need to make sure they're on autoplay. Waffle GCSE 1 seems to be at the top. Seems everyone's picked the same name. Has Blooket ended? Okay, Blooket has ended. This is what the leaderboard looks like. Bella is at the top. T is at the second. Mace is at the third. Okay, do you want me to do another Blooket or do you want to join some of the Kahoots? I think Blooket's a bit easier to do. Okay, one sec. Let me share the game pin from here. Okay, we'll have to put on autoplay afterwards. Okay, I'll do another Blooket as well. It's crazy. I can't believe you guys are so into this. Okay. The games end so quickly as well. I don't have time to... Okay, we'll do a different geography revision. Maybe, would key terms be good? Okay, we'll do some revision here. Nines for Ben seems to be winning on one of the Kahoots. Dottie seems to be winning that one. Okay. Hopefully this is useful GCSE revision for you guys as well, even though it's fun and competitive, of course. Mole seems to be winning that one. Duffy seems to be winning this. T is second. Oxbow Lake is third. Will seems to be winning that. Okay, if anyone hasn't been able to join any of the 1, 2, 3, 4, 5, 6, 7, 8 games we're currently doing at the same time, well, that should definitely have enough people. So Dee Dee is winning, Nor is second, Nines for Ben is third here. I'll show you guys some of the outcomes. Okay, just to let everybody know, we'll be ending the live in about 5 minutes. So another Blooket revision. I can't do another Blooket. I'm only allowed to do one, unfortunately, because otherwise you need premium. Oh, so you've got some hydrograph questions going on here. Blooket's crashed. Oh. Oops. Okay, if you guys want to play again, you can do. If not, it's probably time to log off soon. For the individual who said that No Waffle AI is not letting them reset their password, I've just sent them another email. And I'll try and get round to all of the questions. Okay, any... Okay. Kahoot is freezing. I don't see a Kahoot that's freezing. Question 12. Maybe I've seen this a bit late. I don't actually think anyone's in this game. It crashed again. Okay, I think with that, guys, we are going to have to end the live stream here. It's been lovely. I've been with you guys for 3 hours, so I hope I've been somewhat helpful. I hope you guys can check out No Waffle AI. It's been lovely to have you guys, even if there's been some weird or kind of sad comments. Let's just share the scoreboard. How can I end these games? End now. Okay, so this is the scoreboard for one of the Kahoots. I'm just ending them now. So Mole came... Oh, okay, it's already gone, which is fine. DD came first here. Nines for Ben was second. Debs was third. For this one, T was first. Oxbow Lake second. Duffy is third. For this one, I mean, you can see it already, but Brave Ant is first. Dotty is second. U is third. And then for this final one, I don't think you only answered 7 questions, but still, yeah, okay. And then this crashed. So thank you guys for joining. I'm, as I said, going to be doing live streams pretty much every day for the next couple of weeks for the various GCSEs. Sometimes I do lock-in lives as well, where I study and you guys can study with me. So make sure you join that. I actually don't have time to do a live for computer science. I've got some exams to prepare for. So I'm so sorry I'm not able to do one. I would say maybe watch my computer science live that I did in previous years. That could be helpful for you guys. But yeah, it was lovely having you guys. Make sure you turn up for the next couple of lives. Tomorrow I'm doing a live and oh my God, it's going to be so helpful. I'm going through all of my A-level math, not A-level maths, my GCSE maths notes. And they managed to basically cover all of the content, but really short, in a really short format. So you're going to be able to cover all of the content. And then we're going to do some exam questions. And then we'll have to do our Blooket as our little tradition. Okay. So check out nowafflegcse.com for that. I'll share the link in the chat. If you've got any questions, please email me. See you guys tomorrow. Thank you so much for attending. It was lovely having you. Best of luck with your exams. I'll be posting a TikTok or a YouTube short after your exam. So if you can just tell me under that how you did, that'd be great. See you guys tomorrow. All of the lives you'll be